Welcome back, dear students. We had successfully completed Newton's laws of motion chapter, and today onwards we are going to see work, energy, and power chapter, new chapter. Today onwards we are going to see and see here. First point concept is work done by a force. Work done by a force. See here. Suppose an object is present. An object is present. This object is being applied with certain amount of force. Because of the application of the force, the object suppose displaces some displacement ds, some displacement delta s, then work done is equals to force into displacement, force into displacement, right? This is what is work done. And the next point is, suppose if force is acting by making an angle theta with respect to horizontal, and to move my block to a displacement delta s, to displacement delta s, here f cos theta component, f cos theta, the component of force f cos theta will help to displace my object delta s, right? That is, then work done will be f cos theta into delta s, into delta s. Then this will be f dot delta s. This is dot product. And when we were discussing dot product, I had already told you when two vectors having along with them cos theta, that will be a dot product representation, right? This is what is work done by a force. And next concept is nature of work done. Nature of work done. First one is positive work done. What is positive work done? See, positive work done means, suppose an object is present and displacement is in rightward direction, and force is like this, and if they are having acute angle, and obviously w is equals to f delta s cos theta, and cos theta will have positive value from 0 to 90 degrees, 0 to 90 degrees. So the work done will be, in this case, from 0 to 90 degrees, work done will be positive. Work done will be positive. So we can consider this is positive work done. Positive work done. And similarly, next one is negative work done. Suppose a condition is present where displacement is taking in the rightward direction, but unfortunately force is acting by making an obtuse angle, and the displacement is in rightward direction, and force is in with the angle of displacement, angle with the displacement with obtuse angle. Then we can consider it is negative work done. Negative work done. And the next situation is zero work done. In zero work done, see this object displacing in the rightward direction, but a force normal is acting perpendicular to the displacement. So work done is equals to normal force delta s cos 90 degrees, and cos 90 is equals to 0. Therefore, work done is equals to 0. This says that work done will be 0 when force and displacement are perpendicular to each other, right? And based on these concepts, let us go through with some numericals. And first numerical is a force F 3I 2J 2K 2K acts on a particle from position R1 minus I plus J minus 2K to R2 is equals to I minus J plus 3K, right? And find the work done by this force. Now, work done will be force into change in displacement. So, change in displacement, that is delta R, is equals to R2 minus R1, and which is equals to delta R is equals to I minus J plus 3K minus R1 is equals to minus I plus J minus 2K. Then I, right, I plus I minus j plus 3k plus 2k, and this will be 2i minus 2j plus 5k, and this is what is displacement. And work done is equals to force value 3i plus 2j plus 2k, 2i 2j 5k, then this will be 6 minus 4 plus 10, which is equals to 12 joules. This is what is the work done, right? This is what is the work done for the first one. Now second example, right? Second example I am giving you as the, okay, right, I will give you a hint. F1, F2, F3, three vectors addition will give some resultant vector, and here R1 position is equal to 1 comma minus 1 comma 2, and R2 is minus 1 3, and R3 is equals to 2 comma 2 comma 0. So delta R is equals to R3 minus R1, change in position, that is final position minus initial position into, sorry, and we are getting a resultant F resultant here. Work done is equals to that F resultant into delta R. This is work done. I am giving this question as your homework, and if you having any problem while solving this problem, let me know through comment box. I will definitely try to help you, right? Then third question, a block of mass m is equals to 10 kg slowly slide up on a smooth inclination 37 degrees 37 degrees. Calculate the work done by person moving the block through a distance of 2 meters. This block is being moving through 2 meters. Sorry. If the driving force applied is parallel to the incline. Question A, driving force is applied parallel to the incline. And here the magnitude of force will be equals to mg sine theta, and resolving component probably you are very much familiar because this is our 7th or 8th chapter. So from last so many chapters we are resolving the components so many times, right? Then here that magnitude is equals to mg sine theta, which value is equals to mass is 10, 10 sine 37, sine 37 is equals to 3 by 5. So F is equals to 100 into 3 by 5, 20. So F is equals to 60 newtons. F is equals to 60 newtons, first point. And second one is, the second part of the question is, if force is applied like this, if force is applied like this, horizontal to the direction, then this will be, here it is theta means this will be theta, here it is theta means this will be theta, this is f cos theta, and this will be mg sin theta, mg sin theta. Then as I told you, mg sin theta is equals to f cos theta, then f is equals to mg tan theta, and f is equals to 10 into tan 37, F is equals to 100, 3 by 4, 25, F is equals to 75 Newton. F is equals to 75 Newton. Right? Chalo? It's okay. And this is our answer for the second part. And let us see the last question. A force F is equals to 6xi plus 2 by j is acting, and R1 is equals to 3i plus 8j, and R2 is equals to 5i minus 4j, right? And find the work done in this case. And work done is equals to, we can write F into dr, that is 6xi plus 2yj dxi plus dyj. I am representing in terms of vectors. Then this will be 6x dx integration plus 2y dy integration, and limits are 3 to 5. 3 to 5 for x axis, that means I component. For y axis 8 to minus 4, and this is the what is the work done. Now work done will be 6x square by 2, 3 to 5, 2 y square by 2, 8 to minus 4. So work done will be 3 into 5 square minus 3 square plus minus 4 whole square minus 8 square. Then this will be 3 into 25 minus 9, 16, 64. 3 into 16 plus 16, 64. 4 into 16 minus 64, which is equals to 0. So work done will be 0 in this case. Right? I hope I am very clear from my side. And this is the last one. And before practicing your worksheets, better to follow my class notes. It will definitely helps you. And if you need worksheets, let me know through the comment box. I will definitely post in our Telegram channel, Physics with Jagan sir. And for daily practice sheets and weekend examination papers also, better to follow my Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.